السلام عليكم ورحمة الله وبركاته. يعطيكم العافية شباب وصبايا. Our video for today is the third part from chapter 16, which is about capacitor. In general, the capacitor can be defined as two parallel plates, two parallel conductors separated by an insulator. As you can see here, I have the first conductor charged with positive charge and the second conductor charged with negative charge, and the electric field direction is from the positive to the negative uh, conductor. So in general, the capacitor can be used as a component or electrical device which has the capacity or the ability to store energy on it. And this energy should be in the form of electrical charge to produce a potential difference between the positive and the negative plates or conductors. Now, in general, the capacitor has a capacitance, and the capacitance here is defined as the amount of charge divided by the potential difference. And by the way, this should be a positive quantity. Now, the unit of the capacitor, you can get it from this definition, which is coulomb per volt, or we can call it 1 farad. Now, let us go and take specific case, which is parallel plate capacitor. As you can see here, as I mentioned in the previous video, for the two parallel plates, I have to have positive plate and negative plate. Therefore, the electric field direction is from the positive to the negative, and the electric field here has the same magnitude at any point between Q1 or between the two plates, where the electric field outside of the two plates, either to the left or to the right, equals to 0. Now, as I mentioned, the capacitance is C equals Q divided by V. And again, the capacitance should be positive quantity. Now, we know the electric potential difference between these two terminals, if I can call them terminals or two plates, equals E times D, whereas E is Q divided by epsilon A times D. Now take this amount of the electric potential difference and put it back in the main definition or formula for the capacitance. You will get C equals epsilon naught times A divided by D. From here, you can tell that the capacitance depends only on epsilon naught and the geometry. Q, there is no dependence on Q or V. First example, which is about a capacitor of charge 4 microcoulomb and potential difference of 2 times 10 to the power 3 or 2 kilovolt. What is the magnitude of the capacitance? We know C equals Q over V. We have Q, but we need to convert it from microcoulomb into coulomb, and we know the potential difference. Plug your numbers, you will get 2 times 10 to the power minus 9 or 2 nanofarad. In a circular plate, parallel plate capacitor of charge 4 microcoulomb and potential difference, if the plate separation is 2 millimeter, first find the electric field. Okay, at the beginning, you need to know that you are dealing with two parallel plate capacitors, and these two parallel plates of circular plate shape. Therefore, you can say the magnitude of the electric field, since we have the potential and we have the distance or the separation distance between the two plates, we can use V equal E times D. Therefore, E equals V divided by D, where V is 2 kilovolt and D is 2 millimeter. And pay attention that you need to convert from millimeter into meter. Therefore, you will get the electric field as 10 to the power 6 volt per meter. And again, here, we used the definition of the potential difference to get another unit of the electric field. As we know from the first video of chapter 16, the units of the electric field is in Newton per coulomb. And from here we can say the unit of the electric field is volt per meter. Second, what is the radius of each plate? Okay, to think about this part, we know the electric field, or actually we calculated the electric field. Now you need to relate the radius with the electric field. Therefore, you have to go back in your memory and say, okay, the electric field equals Q divided by epsilon naught times A. From here, I can find the area, as you can see here. Therefore, since we are talking about circular plates, we know the area is by pi r squared. So from here, we can calculate the radius. Even if I ask you to calculate the diameter, you need to calculate the radius using this procedure. Then said the diameter equals 2 times the radius. Okay, this practice and this one too, I will leave them for you, and I will discuss both of them in our lectures. Thank you, and see you in the next chapter.